Hey everybody, welcome back. I hope everybody's doing good. Today we got an exciting topic, another toolbox in our calculus set called the product rule. Let's begin. The product rule tells us essentially that if I have a function, call it h of x, that's a product of two functions, say f and g, and I want to take the derivative of that product, it basically says that the derivative of this product is going to be the first term multiplied by the derivative of the second term plus the second term multiplied by the derivative of the first term. Or rewriting it as f g prime plus g times f prime. So again, the first term multiplied by the derivative of the second term plus the second term multiplied by the derivative of the first term. Let us look at some examples. Suppose h of x is the square root of x multiplied by x cubed plus 1, and I wanted to find h primed of x. If we identify this as f and this term as g, the product rule tells us h primed of x is going to be the first term, which is square root of x, multiplied by the derivative of the second term, which is x cubed plus 1, plus the second term, which is x cubed plus 1, multiplied by the derivative of the first term, which is the square root of x. Continuing, we have the square root of x multiplied by the derivative of x cubed plus 1. This term here is just 3x squared, plus the second term, which is x cubed plus 1, multiplied by the derivative of the square root of x is just 1 over 2 root x. Now continuing, we have a denominator of 2 root x, so we're going to get a common denominator of 2 root x. So we need to multiply this term by 2 root x. So we'll have 2 root x multiplied by the root x times 3x squared, plus this term already has 2 root x on the bottom, so we just leave it as is, x cubed plus 1. So root x multiplied by root x, that's going to be just x. Then we have a 2 here and a 3x squared, so that's going to be multiplied by 6x squared plus x cubed plus 1 all over 2 root x. And continuing, we have 6x squared multiplied by x is 6x cubed plus x cubed plus 1 on top, and on the bottom 2 root x, which is, then we combine terms, we get 7x cubed plus 1 all over 2 root x. Let us consider another example. Suppose I have a function h of t, which is t squared plus 1 multiplied by t cubed minus 4. And we're asked to find h primed of t. Since this is a product and we have two terms, f and g, we can apply the product rule. And we say that h primed of t is going to be the first term times the derivative of the second term plus the second term times the derivative of the first term, which is t squared plus 1. The derivative of t cubed minus 4 is going to be 3t squared, plus we have the second term, t cubed minus 4, multiplied by the derivative of this term is just 2t. Continuing, we can multiply everything out, so we multiply 3t squared through So 3t squared multiplied by t squared, that's going to be 3t to the 4 plus 3t squared times 1 is just 3t squared plus, now we multiply the 2t through this, we get 2t multiplied by t cubed, we get 2t to the 4th, and then 2t multiplied by minus 4 is going to be minus 8t. Continuing, we gather like terms, 2t to the 4th plus 3t to the 4th is 5t to the 4th. Then we have 3t squared minus 8t. Now you notice that the first step is the calculus, or applying the product rule, and the other steps are just simply algebra. So that's often the case in calculus, where maybe the first step is you're applying a certain rule, and then the subsequent steps are collecting terms, simplification, and just using algebra. Now let's look at another example. Suppose I had g of t is t to the 4th multiplied by 1 minus the square root of t. And we were asked, find g primed of t. Well, we would proceed again. G primed of t is going to be the first term multiplied by the derivative of the second term plus the second term multiplied by the derivative of the first term, which is t to the 4th multiplied by the derivative of this is going to be minus 1 over 2 square root of t. We've already done a few examples with the derivative of the square root of t, plus 1 minus root t times the derivative of t to the 4th is just 4t cubed. Again, we can get a common denominator of 2 root t. We write it here, 2 root t. The first term is just going to be minus t to the 4th plus, now we need to multiply this by 2 root t. So we're going to have 2 root t multiplied by 1 minus root t times 4t cubed. Now let us continue simplifying. So on top we have minus t to the 4th plus, we're going to multiply this through here, okay? So we're going to get 2 root t times 1 is just 2 root t, and then minus root t times 2 root t is going to be minus 2t times 4t cubed all over 2 root t, which is equal to, on top we're going to have minus t to the 4th plus, now I need to multiply this 4t cubed through the parentheses, so we're going to get 4t cubed multiplied by 2 root t is going to be 8t cubed times root t, and then we're going to have minus 4t cubed times minus 2t is minus 8t to the 4th all over 2 root t. Now this term is a little tricky, so we're going to work on that. So let's continue on top. We have minus t to the 4th plus, now let's write, we're going to simplify t cubed times the square root of t, which we can rewrite as t cubed times t to the 1/2. Remember, if we have the same base, t and t, we just add exponents. So that's going to be t3 and 1/2, or that's just t7 over 2. So we're going to have our middle term here, we're going to replace by 8t7 over 2 minus 8t to the 4th all over 2 root t. We can gather terms, t to the 4th and minus 8t to the 4th, so that's going to be minus 9t to the 4th plus 8t 7/2 all over 2 root t. Well, that brings us to the end of the lesson. We covered 3 examples. We took a look at the product rule. I hope you enjoyed the lesson. Please click like, subscribe, and comment below, and look forward to seeing you in future lessons. Next lesson, I'm going to be talking about the quotient rule, another powerful tool in our toolbox. Look forward to seeing you then. Take care. Have a great day. Bye-bye.